Hi, hello. My name's Josh. I'm here to talk about .NET. I am a .NET guy. I have given a couple of talks on this topic about a little bit, and I am trying to get a .NET user group started. I'll talk a little bit about that at the end, and this is a little bit of a teaser towards that. But my topic here is about mostly specifically the history and evolution of APIs through the .NET framework, where we will land on minimal APIs, which is what is the current kind of trend, and how we can leverage that in conjunction with MAF, which is Microsoft Agents Framework, which I talked a little bit about in my previous talk, to build AI-driven apps using .NET. And, okay. So yeah, again, we're just going to talk about the evolution of APIs in general, and how we landed where we are from the beginning in 2002, where .NET was released, up until today with minimal APIs. Get a little bit of a refresher on what MAF is and what you can do with it, and do a little teaser of the demo project that we'll be looking at in more depth in our next meeting with the .NET user group, and which will be on April 14th. I'll talk more about that at the end here. But let's get started. So if APIs, if you're unfamiliar, stands for Application Programming Interface. And these are basically just the endpoints that your modern applications speak to in order to get stuff done. So you're on your phone, you're playing with an app. That app is sending messages to an API to log you in, to save your data, to bring your results, to load your cat pictures, whatever. The APIs are what facilitate the communication. And so .NET has evolved this drastically over 20 years. We've come a long way since the first early days of .NET, and minimal APIs today represent kind of a combination of all of the different things that have changed over the years. And we have a much smaller footprint, much faster, soup to nuts story that will get you something that you can do in production pretty quickly and pretty powerfully. And again, we're going to kind of start from the beginning here with .NET 1.0 in 2002. This is the first release of .NET, where everything was a web page. It was kind of this mirror idea of building for Windows, but on the web. So you can have this kind of visual editor. You can drag and drop components onto the page. You had code behind with C# or Visual Basic, but everything was a page. And so building, an API interface on top of a page was really difficult. And you had to use, they did have what was called SOAP, Simple Object Access Protocol. That was their answer to APIs. You would make these gargantuan ASMX files. Everything was XML. It was ugly, it was bulky, it was clunky. JSON wasn't even a thing yet. So it was a lot of markup. You had view state. It was great for business applications. People would, build, really cool looking websites pretty quickly. But if you were trying to do anything really powerful, you could go through 2,000 lines of XML that no human was ever meant to read. And if stuff failed, you had no idea why. It was a mess. REST was still not really a thing. It was just HTTP for transport. And just to do a little simple hello world example where you could just call your API and get that result, you needed first the ASMX service that defined the endpoint. You needed the code behind that defined what the endpoint did. You had to register that endpoint in your web config file. And then you had all of these files that had to basically be in place just to do one little endpoint. So it was a nightmare, it was a mess, but it worked. Everything had to match, your namespaces had to match. If you wanted deployment was a nightmare, debugging was crazy. Like, it was just the early days. I'm surprised, I'm amazed we survived it, but we did. And Microsoft, in true fashion, decided we need to do better. We're going to make a new set of libraries called Windows Communication Foundation. And in true fashion, they made it better by making it worse. They made it even more convoluted, even more complicated. They did unify the stack with SOAP and all the different types of communication protocols that you could interact with. And enterprise loved this because you had a lot of control. You know, you could really do really meticulous things, and you could ensure that everything worked the way it was supposed to. But in order to do that, you still had this kind of same compromise of like, you know, 400 to 600 or even 1,000 lines of XML defining every single endpoint. And if any of that was wrong, you really didn't even get a good error message to tell you what was wrong. You were still kind of going blind. So you really had to know what you're doing, which is, you know, for someone advocating for .NET is something that admittedly is pretty common. But we got better, I promise. It was very verbose. The config files, it wasn't lines of codes, it was pages of code. And they kind of bolted on REST into that, and it got better, but it was never really a true implementation. The learning curve was crazy. You really had to have really specialized knowledge. And it still has suffered from the same kind of problem of, you know, you had to define a service contract that defined all of your endpoints in C#. You had to implement those services separately as using that interface as a base. Hosting it was crazy because your development machine was completely different from your production machine, and your application configurations in the web config, everything had to be exactly right. And if anything was, you know, left over or you didn't, you know, pick the right protocol from, or HTTPS secure to non-HTTPS, none of it worked, and you had no idea why. So it was very powerful and gave us another, you know, a level of abstraction over the communication, but it was still really convoluted and messy. So we get now to 2009 with ASP.NET MVC, and this is when Microsoft kind of embraced the MVC story that I think Ruby was, I don't know if I don't want to say they invented it, but they certainly pioneered it, or, you know, brought it to the forefront, and they kind of started to adopt it. And so you got routing, you got controllers, and it was a familiar paradigm that developers outside of .NET recognized, and Microsoft recognized as being something that was a much cleaner pattern. And so you had this clean pattern of controllers that gave you the entry point to your API. And so now, instead of like defining everything in web config and having to register every single one of your services, and then your clients having to like download that service in order to just to communicate with it, it was much more stateful, much more declarative. And so you can connect to these endpoints using just regular HTTP calls. And this is where we start to get much more modern, familiar the way things work today. And so the routing was pretty intuitive. The controllers were testable. You could actually run them in isolation, run unit tests on them. You didn't have to like have these like gigantic bloated processes just to get a single little endpoint running. JSON started to come out, but it was still very view centric. Like the view in MVC is model view controller, where view is the web, pretty much the web page that you see. And it was still kind of focused on that. API was kind of like a piggyback. So you got the feature, but it was kind of an add-on, and it was never really a native experience. So you were still kind of going against the grain, trying to build these APIs for your applications. You had to register stuff in global ASACs, and it's funny because if you only needed to override something, you'd put it in the global ASACs file, which is just kind of like a startup file, and you would just kind of dump everything in there, and eventually you would end up with another gargantuan file of spaghetti code that everybody was afraid to touch, and everybody knew that you didn't touch because then everything shuts down. So evolution, but still the same kind of problems. However, it was definitely a much more simpler setup. We no longer had to register a bunch of endpoints in web config. It was, again, much more declarative. You basically just defined your routes in your controllers. The controllers were basically just the entry points for the requests. You have a web page needs to make an API call. It'll just initializes the request. The controller sees it, knows what to do with it, gives you the result. We're getting there. We're getting there. It's getting cleaner. It's getting faster. It's getting more intuitive. And as developers, you had less boilerplate to write and just a better experience. Then they finally decided to give APIs their own true space. and that was the introduction of ASP.NET Web API in 2012 with .NET 4 and 4.5. This is where APIs actually got their own namespace. They actually got their own set of classes that was not piggybacked onto MVC. It was actually kind of a separate implementation that was specifically for building your APIs. So now instead of having to build a web page and tacking on API endpoints to that website, you actually had a dedicated API surface that you could create so that you could service your application, service your website, service your mobile apps, whatever it is you needed to do. And you didn't have to intermingle that with your website. And so you got this kind of separation. It was a leaner experience. They kind of started to roll things into defaults, so it was easier to get started. And there was definitely JSON first by default. You could use attributes on your classes, on your controllers to control routing so that the endpoints were much more intuitively surfaced. And you could, it was just easier to consume, it was easier to develop, it was easier to build, easier to debug. You could actually look at the code and know what it was doing and not be digging through thousands of lines of XML. But again, it was still controller heavy. You had to create an entire controller class just to make a single endpoint. And if you had, say, a controller with, you know, maybe 15 API endpoints for like user authentication or user login or whatever, if there were any dependencies on, say, one or two of those, you had to throw the entire dependency chain into the controller, whether one endpoint used it or all of them used it. So you might end up with a controller with like 30 dependencies that you had to load every single time. So it was still clunky, but it was better. Again, it kind of followed the same pattern as ASP.NET MVC, but it was kind of more of an isolated space. So you still had to have global ASEX, you still had to have your configuration startup, you still had to have your controllers, but they were dedicated to the job of API. Then came ASP.NET Core. This was a total reset for .NET. This is when they decided to go full on into open source, full on into cross-platform, and they basically rebuilt the .NET framework from the ground up back to 1.0. And so it was .NET Core 1.0 in 2016, and this was a framework that basically unified their development story across every platform. Your code that you wrote with .NET could now run on Windows, Mac, Linux, Android, iPhone. All of the runtimes could be compiled from a single code base in C#. And so they took that opportunity to basically rewrite everything. And so the .NET framework still exists. I think they're at 4.8 now, but this is the future. This is where if you haven't done .NET and you're interested, this is where you start, .NET Core. Again, cross-platform, and it really kind of lead into this idea of middleware, which I think a lot of other modern frameworks like Node.js use, where you've got your application, and instead of configuring everything within that, you have these injectable components that you just register, and then the system is smart enough to kind of integrate them into your system. And so they leaned into that really heavily and just made it much more modular. So now it was easier for you to inject different components into your application, but it was also easier for you to get started because they also consolidated a lot of defaults that drove the way your application worked, so that you could literally just kind of file a new project and immediately have something useful. There was still some configuration that you needed. Again, controllers were still required. The startup file was still required, but it was definitely faster, more modular, more unified, and just a really great step forward. Again, you had a program file where you did all your registrations. You no longer needed this XML web config file with like a gargantuan list of registrations. You did it all declaratively with C# code, so it was much more readable and testable. They also moved the settings into JSON instead of having web config files with XML files that were readable but messy. JSON is sleek, slim, and just more manageable. So again, still controller based, still had this big infrastructure in order for you to run it, but it was sleeker, faster, and just much more intuitive. But that gets us to where we are today with minimal APIs, with .NET 6. They basically kind of rebooted the story for building APIs specifically. They gave them their own, just like they did with ASP.NET MVC versus ASP.NET Web API, where Web APIs got their own space. Minimal APIs got their own space, where now you can just declare these APIs almost as just a .NET program. Basically just do file new, initialize the program, here are my endpoints, and that's it. There's no web config, there's no startup, there's no controllers. You literally just define your endpoints, and we'll see what that looks like. You can make a single file API that could drive a production level application with just one file, maybe a couple dozen lines of code. And since the framework is so robust and extensible, and with that middleware so injectable, you could bring in external libraries to add things like authentication, rate limiting, all kinds of cool stuff. And all you do is just declare it, integrate it, and then just focus on what your code does, what your application does. And we truly get to a great point in the .NET developer story where you don't have to spend 30% of your time getting set up and then finally be productive. You just turn it on and focus on your application, your code. And so you can see here, this is it right here. Boom, this is an entire API right here. You basically just say, create my web application. You map an endpoint where this is the path that the browser would call to execute it. You have an input shape, in this case, a string for a name. And then that just gives you an output of, in this case, a string for hello name. And then you run it. That is it. 3 lines of code, you have a full-blown API. And it's not that difficult, like I said, to add additional integrations to make them more advanced and complete. In this case, we add an authorize attribute to make sure that you're authenticated, and the framework takes care of that for you to automatically redirect them to a login or enforce the login. Your summary request, in this case, this is a custom shape of an object that determines the parameters that come in, and then gives you the result that comes out. As you can see here, we just attach an extension method, require rate limiting, and give it a parameter. We tell it what it produces, and then we can even include Open API to document it automatically for you. With these few lines of code, we have an authenticated, rate limited, documented API endpoint with, what is that, 8 lines of code. And now all you have to do is now go define this summarize async method for whatever it is that your application does. So you just define it and get started, get going. Very, very cool. And this is why they're great for an application like I'm going to show today. I mean, AI is stateless by nature, so you just need an API call that you can just send it all the information that you need it to do, get the result, and move on. Super small surface area, just define what you need the application to be. It's super fast to build, exceedingly easy to deploy. You just basically just push it out to either regular web hosting, Docker, Azure. Since it's cross-platform, you can run it on Linux. It doesn't matter. The fluent chaining is that we just had like authenticate. What was it? OpenAI or add routing or whatever. Like it's very intuitive, declarative, and you just wrap your abstraction for AI over it, and you're good to go. So it's a natural fit, and that's where another abstraction comes into play, which is MAF, model. Oops, it's not abstraction framework; it's agent framework. Sorry, Microsoft Agent Framework, and this basically is just an encapsulation of all of the different AI services and framework implementations that Microsoft has created over the years. Just like the APIs evolved over the years, their AI story has evolved over the years. And if you look back at the previous session I did, I'll walk you through that entire story. But it encapsulates all the AI, it standardizes all the interactions, and all you have to do is just register everything just like we did for the API, and you can focus on what your application actually does. It keeps everything very simple, modular, and extensible. And so you can see here, just like we did showed in the previous point where you just map your endpoint, we have this chat. We basically map a post endpoint. We have the request where we have some, maybe it has a text or whatever, a question. And then, your model runner, this is your class that defines whatever it is that you want your agent to do. And then you just run it. You tell it, hey, take their request and run it and give them a result. Boom, done. API is out of the way. And all you can do is focus on what your application does. So I'm going to show you what this looks like. Well, I'm going to give you a teaser for what this looks like. If you want to see the source code, definitely come check out the next session, because we're going to dive deep, show you every line of code. I'll show you every prompt. We'll even expand it in real time and show you something really cool. But for now, we registered it in just about 40 lines of code, not a single controller, no startup file, but we have ultimate flexibility. So let's see what that looks like. This is the application, right? This is exactly what I showed you in the beginning. Let me make this a little bit bigger. We create a web application. Tell it I'm making an API, and I basically just get the configuration. These codes basically just get the config settings from here. So I'm telling it which provider I'm using, OpenAI in this case, which model I'm using. It's all just set up. And here's where we add the chat client here. And this line of code right here, add chat client, that's MAF. That's the Microsoft Agent Framework. This is the built-in chat client abstraction that lets you pass in whatever model you want to use. In this case, it looks at the config and it says, hey, if you're using Gemini, go ahead and instantiate it with the Gemini key and the Gemini model. If you're using OpenAI, initialize it with the OpenAI model and the OpenAI key. That's it. Everything else is completely the same. There isn't a single line of code switch statement that says if Gemini do this, if OpenAI do that. The abstractions in both the agent framework and the .NET framework in general let you just write your application code, and it's going to use whatever model or AI you send it. We do have a broad context provider, which is going to be, I should probably tell you what the application does, right? The application is, and let me show you what that looks like. Sorry, I should have led with that. This is a brand engine, content engine generation studio. So what we have done is we have defined a fictitious company, fictitious security company, and we want to be able to generate social media posts, a blog outline to be able to write blog posts, ideas for videos that we want to use for promotion, and maybe some images that we're going to use for our blog post or whatever. And so in order for this to function correctly, we need to be able to, of course, define what our brand is. And so we have, in this case, just a really quick markdown file called Borderline Security. It's a fictitious cybersecurity company, and just tells it, okay, well, here's what our services are, here's our audience, just a couple of, just a little bit of a definition of who we are. And the agent framework is actually able to use this context like intuitively. This is a built-in method to the agent framework that can understand this document to make sure that every AI call that you send it, process it through that brand. So you define that once, and every one of these operations will inherit that branding. And that's what the framework lets you do. And it builds the agent using whichever chat client agent you build, whether it was Gemini or OpenAI. And then we go ahead and proceed to build the actual API endpoints. So first we have a status endpoint, and all this does is tell you, this is what the thing does. This is just static strings that tells the status that says, yes, I'm up, and here's what I can do. But then this is where we define what we actually can do. So I have a content endpoint with social, and this generates a branded social media post. I have the blog outline, the video idea, and the image prompt. And these represent each one of those hittable endpoints that your application can call to get these results. And so if I go in, if I run this, I'm going to go ahead and launch this. and I go to an API REST client, and I call that endpoint. So you can see here that says status. That corresponds to this endpoint here, status. And all this is doing is returning, again, just a list of what it does. So if I execute that, then of course, that's what I'm gonna get. I'm running, I'm up, this is what I can do. Now I can say, hey, give me a social post with a topic. So that's this endpoint corresponds to that one that I showed you. And say, okay, give me why small businesses are #1 target for ransomware. Send that. It's going to go ahead and execute your AI prompt, and this is the result. So this is what your application is, whether it's your mobile app or the app that I showed you, is going to use the results to actually give you the output. And even includes hashtags, the call to action button, everything that you need. And we've got all of these endpoints for generating the video, the image prompt, and one that even does them all at the same time. And that's actually a really cool example, because here, this one, the generate daily content, this one does them all in one go. And what's cool about this one is that when we execute it, if we look at the service that calls that, this is leveraging a built-in .NET framework feature that allows you to basically execute all 4 of these methods in parallel simultaneously using multi-threading. And then when they're done, aggregate them into a single result and send them to your API output so that your web app can put them all in one result. And that's just leveraging the built-in framework stuff that .NET offers. So here's what it looks like. Go to the app. So I've got, let's do a topic on Wi-Fi safety tips. I want a social post, generate that. And there we go. Gives you a nice copy and paste social post, bunch of hashtags, and includes a CTA call to action for your LinkedIn post or whatever. Now, here's where it gets cooler. If I go into my configuration, I can change the brand entirely. And I'm going to change it to this cafe called Casa del Cafe. And what I've done for that is I defined a completely separate brand with its own identity. And if I go back to my application and let's reload it, if I tell it I want to do like something about Wi-Fi, when we did our previous brand, it obviously understood the brand and said, hey, don't get compromised, use safety protocols or whatever. But if I send Wi-Fi, a very tech topic, to my coffee shop brand, you'll see that the results that I get in this case are going to be very different. Here, it's saying, hey, come work, try our free Wi-Fi, and get your coffee on, and frames it around that brand. So even though it's the same application, it has the same prompts, it has the same definitions, the same outputs, because it's able to understand your brand, it tailored the message to that brand. And you as a developer didn't have to tell it to do that, because, or rather individually at this level, it understood it foundationally and fundamentally by the integration that the MAF gives you. And just to show you here, the daily content, these are gonna do all 4 of them in parallel and give us a single output, even though they're all executing differently. It aggregates them together, and now here we get all 4 outputs. The social post, how to make a perfect cafe at home, the blog post outline, the video idea, and it even gives you the image prompt, which you can then take over here and put into a service like FreePick and get a nice set of pictures for your blog or whatever. Come on. There we go. And yeah, I achieved that by just literally changing one line. And of course, we could also change it from OpenAI to Gemini. You could change the model if you want something faster, you want something more, smarter and thinkier or whatever. But yeah, it's really powerful. And again, it was so simple to register. Now, if you want to see the actual prompts, you want to see what it's actually doing under the covers, you definitely want to check out the next session because we're going to go over it in complete detail. But that is the power of minimal APIs and the Microsoft Agent Framework. The minimal APIs, again, very extensible. We can add authentication, validation, caching, response streaming, rate limiting, documentation, health checks. All of these things are just a single NuGet package inclusion away. Add a line to register it to your endpoint, and you got a robust API in no time. And you can get up and running, building, and making some really cool stuff. And that is minimal APIs in .NET and MAF. If you want to hear more, definitely encourage you to check out rgvdevs.net. I am talk all about .NET and what it can do for you. And this doesn't end with this. There's mobile apps, building web apps. You can do all kinds of stuff with .NET. And definitely check it out. And of course, April 14th, we'll be doing a deep dive into this very project. I'll show you all the prompts. We'll add some new features live on the fly and go over all the architecture and talk more about what you can do with that. So that is all I've got. And thanks a lot. Let me know if you have any questions. Oh, come on, nothing. I didn't teach you everything. Oh, you want a deep dive? April 14th. Join the event. You get the source code. You'll get everything. You can build this thing yourself and have some fun with it.
No questions. There's no questions, and thank you very much for the presentation. So we'll take a slight break here and get ready for the next one. Thank you.